Hi everyone, GMGM. So nice to see all of you join us today again. Hope you all enjoyed the launch yesterday evening. Today we have another super exciting workshop. I'm inviting Sandipan from the Shardeum team to the stage now, who's going to share all about the Shardeum Dapp Boilerplate and how to build prototypes. So please say hi in the chat. Pop any questions that you have in the questions tab. And yeah, let us know what you thought of the launch yesterday. Let us know if you already have an idea on what to build, all that good stuff. I can see Sandipan is joining us now. Hi, how are you?
Hey, hi everyone. Hi, Clara.
Hi. How are you doing today?
I'm doing good. How are you?
I'm all good. I'm all good. Excited for this workshop. Also, let us know, guys, in the chat if you joined the Intro to Shardeum workshop. It'd be really cool to see whether there's some people who joined us for that as well. But other than that, and that's kind of my introduction done, and I'm just going to hand over to you and let you get started.
Sounds good. Thanks a lot. Awesome. Hey, hi everyone. This is Sandipan. I work at Developer Relations at Shardeum, and today I'm going to give a brief info about how Shardeum network works. What are the changes? There are a lot of similarities also when it comes to the network side and deploying dApps because it's an EVM compatible network. But also, what are the changes? And we will get a demo a quick boilerplate in which with using which you can quickly develop your dApps. And I know that this is a long form hackathon of 1 month, but it's still if you have the tools already built into on a boilerplate, it's going to be faster to build on top of that. So hopefully that will be helpful. Let me just quickly start my screen share. Let's just do an entire screen from the beginning itself because anyways, I'm going to be presenting. So yeah, to give you, let's start with the kind scalability. So again, we did a workshop a couple of, I think, a couple of weeks ago. But that workshop was mainly to give an overview of what Sharding is, our ecosystem, and what our goals, the so far success, the roadmap, those kind of stuff. But currently, we are going to in this session briefly, we are going to quickly discuss on how Sharding network actually works. But before that, the scalability bottlenecks, I think it's important to give the set up the environment on why even we need an L1 in 2024. So that's why is Sharding even required? So I think one of the biggest limitation is the throughput limitation. Current blockchains, popular blockchains like Ethereum, are only able to do 24, 26 TPS, and they are able to they're not able to scale even further. Even though if you add hundreds of thousands of nodes, it doesn't matter. It will only be able to do particular limit. Then finality, between the time in which the transaction is processed and between the time and when it is actually considered as final, that's also an important factor in a real world use case. But um and for example, even if your transaction is confirmed, it's generally, in case of Ethereum for example, it's not considered confirmed, or it's generally advised that until 256 block confirmations, you cannot really consider your transaction as confirmed. So 256 block confirmation, it's going to be a long time period. So you need to wait for that much time. Then block size and block time is going to be your limit, because traditionally blockchains, how they work is based upon blocks and block the block size and creating blocks at every frequent interval. You'll also understand an important differentiation is Sharding doesn't form blocks, but it is a blockchain. So it's very interesting, and I'm going to be talking about that. But technically, it doesn't need to form block, but we'll get to that part. And interoperability, the whole thing with L1s, L2s, now even L3s are coming up. When you are dividing the network, the liquidity into so many different networks, that interoperability becomes a challenge. You need to bridge. Then some bridges take a lot of time. Some bridges your funds get stuck. It's a total mess. So these are the current scalability bottlenecks. And I think this is also most of you, if you're if you have been learning in Web3 for a while, you must be aware. If not, like the blockchain trilemma is like you can only achieve two of these like three um, like points or factors at a particular time. So for example, if you have security and decentralization in some way or other, you are going to be limiting scalability. This is a perfect example of Ethereum. Ethereum is highly secure, Ethereum is highly decentralized, but it's not able to scale up further. So like that's exactly what we are trying to achieve with Shardeum. We are trying to achieve all of those three at the same time, and that's exactly the most interesting part. But again, like let's come to the part on what is like Shardeum and what is sharding. So before we jump to Shardeum, let's quickly understand about sharding. So sharding is not a Web3 concept. If you are familiar with databases as a developer, you must have already worked with it. So it's a concept of basically splitting your database into smaller chunks so that it's easier to work with and faster to read where your data is and get access to that. So that's exactly what we are doing in context of a blockchain. So imagine a network like Ethereum in which there are hundreds of thousands of nodes. All the nodes are working together to process all the transactions. Like even if it doesn't matter who is sending the transaction, what the transaction is. If a transaction is coming onto the Ethereum network, every participant, every node is validating that transaction in some way or form. And everyone is required to, like, not everyone is required, like a majority of the consensus is required. So you can understand that it's so inefficient because if you want to have a single transfer amount, why do you need to bring in hundreds of thousands of nodes into like the consensus and you need to work on that? Like it's very inefficient in that case. But again, it was ahead of its time and it's when it was launched. And at that point of time, we didn't used to hit the TPS limit. So, and it's also introduced a lot of cool things like EVM, which we are going to talk about also. Again, coming back to the topic of sharding, each shard is capable of processing its own transaction. So what happens is like, imagine Shardium as a very like connected connected nodes of shards. For example, you can imagine that, for example, let's take a, I think there is a diagram here. It isn't. Okay, yeah, there is a diagram in the next slide. So let's just quickly process this one. So every transaction is processed by every node. This is in case of Ethereum. And in Shardium, the only difference is that instead of every node, it's being divided. And how it's divided, we are going to learn in the dynamic state sharding. So dynamic state sharding is the key innovation in which like Shardium is bringing to the EVM network in a sense that um, like instead of having the entire network process, what we just discussed, right? So we have shard one, shard two, shard three, shard four. What happens is like when you send a transaction to Shardium, each of the transaction creates an access list. So if you're familiar with EIP 2930, so each of this transaction creates an access list, and based upon that access list, the transaction is routed to like a consensus group is formed, and then that consensus group, only that consensus group processes the transaction, and rest of the groups are doing their own thing. They're processing other transactions. So this is the way on how like transactions in Shardium are able to much more effectively work on a higher TPS, because not everyone is doing the same work. This group is doing different work, this group is different work, and there are there can be hundreds of shards altogether. So, and in case of like wide dynamic and static, so there have been blockchains in which they have done static state sharding. So for example, it's fixed on, these are the nodes that will work on this address range, these are the nodes that will work on this address range. But in case of Sharding, it's dynamic. So the address range and how these consensus groups are formed are dynamic. It does, so it's difficult to predict. Like it's not possible to predict that which address list or which access list or which node even will store which part of the data. So everyone has a chunk of the pie, but no one has the entire pie. So they like, so it's like efficient in that way. So using just a chunk of the pie, you're able to do your work and process the transaction, and the rest of the pie does its own thing. So that's basically what Sharding is bringing onto the network. So dynamically state sharding, auto scaling is also one of the concepts which we are going to see in the next slide. But EVM based, so Sharding is entirely EVM based. So if you have dApps deploying, like if you have deployed dApps in any other EVM network, you don't need to change any um, like Solidity in your like in the any code in your Solidity file, like it can be directly deployed to Sharding network, and no fee markets. And also one of the more interesting part in Shardeum is that since there is no competition, coming back to the like everything is tied together. Since there is no competition of block size and block time, because the network is able to auto scale, which we are going to see in the next slide. There is no fee market. Fee markets are introduced so that it's like because there's a limited capacity, right? Only a block can only hold this much amount of transactions. So everyone is trying to price their in that, hey, I'm going to pay $5 more to get my transaction in first, and their transactions are prioritized. But since Sharding is able to auto scale, there's no fee market required. If there are more transactions, the network will grow accordingly. So if the network is doing 750 TPS, these are the standby nodes and the blue ones are the active nodes. So if the network senses that we need more TPS, it will just bring in more nodes from the standby to the active pool, and now you have a higher TPS. So there is no competition for fixed amount of block space. That's why you're able to have a fee like a constant fee market, and you're able to scale auto like your the network automatically. And this auto scaling again is a Web2 concept. Amazon in an AWS server, when if you say let's say the take an example of Netflix, it's not that Netflix is always having the same amount of computation. It their servers scale up and down based upon the number of viewers. So that's exactly what is happening in Sharding blockchain based upon the transactions. Now coming to the interesting part, the Shardeum Dapp Boilerplate, and now we are going to jump to the actual demonstration. Yeah, hopefully my entire screen is visible. Yeah, I think so.
It is,
So
yes.
this is Shardeum Dapp Boilerplate. Let me just drop it in the chat so that if you want to follow up with the workshop, you can. So yeah, this is what we are going to talk about for the rest of the session. This is Shardeum Dapp Boilerplate. It's a inbuilt, like I've built it from scratch, no external components. Even the wallet is built from scratch so that you can understand how wallet works, how you can read transact like a balance and showing the wallet address, how to get that. So there's no tools being used. So this is very, very built from scratch so that it's deliberately built for that for so that you understand the basic concepts. Let's just clone it and do an npm I. So yeah, feel free to follow the session from here also directly if you want, or I guess you will also be getting recorded video, so you can follow that later line by line, but you can probably for now just watch. Let's just quickly start and see what are we getting with it. Yeah. So it's configured with Hardhat. Hardhat is a tool which gives you an environment to deploy onto local network and also to all the networks. And what is it? We have scripts, we have deploy.js, we have deploy nft.js. So let's just go do a run. That will be more simpler to explain. It's running. By the way, it's built with Next.js and ethers and Hardhat. So you will find all the details on the README also. But so this is how it looks, a very basic stuff and not very good at front end, as you can see. But yeah, we are going to work with it. So this is what you get. So you primarily start with three things. One is an RPC page, one is an NFT page, and one is a DeFi page. Let's connect our wallet first. So the RPC page, so each part of the boilerplate does like wants to represent something or the other. So the RPC page is mainly to represent of how you read stuff from a blockchain, an EVM compatible blockchain. And again, like it's same as of Ethereum. So you will see if you are familiar with other EVM network or Ethereum, like there is no changes. So for example, if we query the network ID, we are getting 8082. 8082 is the Shardeum test network ID. Then if we query the latest block number, we get the latest block number. If we query the gas price, you will see the gas price. But again, like the gas price in Shardeum is constant as we just discussed because everyone is not racing to get into the same block. then balance of an address. So this basically represents, and let's just get to the code part. Again, very basic stuff if you're already aware of it, but as a starting point of view, I think that boilerplate gives something to every like skill set. So if this is very basic for you, probably you will find something in the next page or the next page, but it like you will find some resources which you can reuse in your DApp while building for the hackathon. So yeah, as you can see, we have actions for the network ID, and then we have similar functions of what you're trying to do. So if you're trying to get a transaction count of the account, or if you're trying to do ETH request accounts, so all of these are EVM JSON RPC calls. And this page just wants to demonstrate how to make those calls and what are the variables you need to pass, these kind of stuff. Again, I understand like in your DApp, you will need, if you're not using any built out wallets like Rainbow Kit or something, like you will need to add a method to query the balance, query the account. So these are basic stuff which you will definitely need in your app. So you can just copy paste from here, or you use this boilerplate from that. And the next page is the NFT page. Let's go and watch the NFT page. You get started with a very basic layout of NFT minting page. You have the NFT, you have the cost, you have the mint NFT button, and again, like we have the NFT.js file, and all the functionality you will see in the NFT page is in it. Let's just, yeah, let's just close. Did I close? We just need to close the ABI. Yeah. So very basic stuff. We have the image upload to IPFS, and also how images should be. So let's just give you a context of what this is. Okay, I think we may need, it will not directly open here. We need to go with Brave, I think. Yeah, so this is how an NFT metadata should look like. You should have a name, you should have a description, and you should have an image. And this image is what will be shown in your wallet. So that's how, if you are not a familiar, something new you learned. So this is how an NFT metadata should look like. Very basic stuff of name, description, and image. Okay, let's get back to the code. So yeah, the image URI, we are using Ethers. We are consider like connecting our wallet with window.ethereum and getting the signer, getting the wallet address, then we are minting that. So if you are not familiar, let's just go ahead and deploy a contract on the Shardeum network. Where is my hard hat config? So you will see a network already configured, HTTPS hackathon Shardeum network. Also, one important stuff I think in this part of the presentation we can share is, so there is, let's go to the Shardeum doc. So there is a Shardeum Sphinx network, which is publicly available and which is our current public beta net. But we are currently in our rush towards mainnet. So we are at the end stages. So we are breaking a lot of stuff in this network. So for this hackathon, specially, like we created a temporary network so that you have a stable network where you don't need to worry about any breaking changes or the network getting reset while you're building in the middle of it. So this is the Shardeum Developer Hub. We also have shared this link in the Encode Club Shardeum channel of the hackathon. So if you go there, you will find it there also. But let me just share it here. Okay, I see a couple of comments. I'm going to comment about that. We'll get back to the comments. Thanks a lot for the good comments. We'll get back to that, but we'll address it one by one. But yeah, I just shared the link. Uh, you will see. So this is the most important part: the RPC chain ID, Explorer, and Faucet. So definitely, if you want to have a stable experience, don't deploy on this network currently for the hackathon. Definitely deploy on this network. This is built just for you, so there will be no breaking changes. So that's why you're seeing some raw stuff like direct RPC links and direct like network access. So definitely also don't spam for your fellow hackers because we have not set up the guards with the domain ID and all those stuff. So this is very raw, and you can use that for developing your dApp onto this network. So yeah, this is the RPC which you are going to use, by the way. Okay, and we have to configure. Do I have? I don't. Okay, so it's fine. We can directly just do it. So for this presentation, again, like I have created a wallet specifically for this. I'm going to be showing a private key, and this doesn't hold any real world. So there's no use of reusing this private key, but just for this presentation, let's just do it. Cool. I think we are all set. So yeah, I think we can do, let's just stop this for a while. Okay. So we have the deploy nft.js file. This is definitely not it. This is it. Yeah. Deploy nft.js file. It just deploys a basic NFT file, like NFT smart contract ERC 721. If you want to see what that is, we can see that also. Everything is included into the boilerplate, so you don't need to worry about anything. If you just do an npm install, you will be like everything is there. So this is the NFT smart contract, very basic stuff. ERC 721, we are reusing all the other stuff. The only thing is like we are just specifying a minting price, and that's pretty much it. So let's just deploy. Let's just wait for a while. And meanwhile, let's go to source pages, nft.js. So this is where you're also configuring. So if you see, we have created a contract instance here of the NFT contract. So this is what we are going to be replacing. So yeah, our smart contract is deployed. Again, like no change in Solidity code. It's an entirely EVM compatible network. So no code change required. And where is our, okay, so this is it. So we have included the NFT in the smart contract instantiation. So now it's configured. That's pretty much it. Now let's just do npm run dev. Everything looks good, no errors. Let's refresh. Let's connect our wallet. The mint NFT button is available. Here we have a pop-up. It will ask for one SHF. Everything looks fine. Cool. And that's pretty much it. Like a fully configured NFT minting page from scratch. All the functionalities built in, no external libraries used, apart from obviously ethers and all, like though that you have to use. And the NFT is minted. And that's the power of Shardeum Dapp Boilerplate, and using that, like using just this, if you like start with this as a like starting point, and then build on top of it of like displaying a gallery and all those kind of stuff which you can think of while building the hack. Like I think that will expedite your uh, like hackathon building process by quite a lot. So open the Explorer. While the Explorer is opening, let's just see. So yeah, it's the transaction is confirmed. Let's give the Explorer a time to open. Where were we? So yeah, so we demonstrated two pages, right? We demonstrated, where is it? Where is it? Here it is. So we demonstrated RPC, we demonstrated NFT, and there's also a DeFi page for the people who want to like add some more details or some more like next level, go to the next level of working with DeFi. So you have a built-in Uniswap like swapping interface in which you can exchange between TST and SHM. This is going to start through an error when you start the boilerplate because you need to be configuring all the so you need to deploy a Uniswap router and also the ERC20 tokens, and you need to configure those in the DeFi page. Again, each page has its own functionality. Like so, the DeFi page has the DeFi.js file. it has the everything, the UI and how the swapping is handled. You will also see in the config file. So we have the TSC token, we have the SHM token, we have the Unisub router. You need to deploy each of the smart contracts, all of the how you will deploy. That is also here. Like you will use the deploy swap token, deploy TST ERC20, and also you can just directly go to Unisub's GitHub and deploy their router contract. Just you can use Remix also if you want. So using that, you need to come to the defi.js file. Again, going in depth into this might be a little difficult for beginner developers, and also everyone has access to this repo. You can dive deep into it if you are comfortable to that. But definitely before you jump to the DeFi page, have an understanding of how dexes work, what are the most important contracts. Otherwise you will get a little bit overwhelmed of what's happening here and why it's happening. But again, for simplicity's sake, everything here is using Uniswap v2, which is very old, but it still holds billions of dollars currently. But it's very old, but it's easier to understand than v3. So it has lesser input styles or functions on how you handle the swapping. So it will be more beginner friendly, but still you need to have an understanding of how a DEX work to work with the DeFi piece. So definitely read up on that. And yeah, that's pretty much it. I demonstrated the main functionalities of the boilerplate. Again, like even if you see the modal and how like the disconnect connect wallet, nothing is using an external library. Everything is built in. So for example, the wallet, we have the component folder header.js. So all of the files you will find here on how the wallet is working. So everything from scratch. So that gives you more idea and more in-depth knowledge of how things work in a app and what are the components you need to configure. So yeah, that's pretty much it. Again, to remind you, definitely don't go to Shardeum docs and use this network. This is a public network which may be breaking at some point of time. Use the network which we shared in the Encode Club Discord channel. And this is the page you will be redirected to. And here also, like you have an embedded faucet. So just put in your wallet address and request the faucet. You will get if you connect your configure your MetaMask with this network, you will see that your funds should start showing up. Again, like even though the chain IDs, again, I'm saying repeatedly because so that you're not confused, the chain ID is same. It's 8082 here, and also to the public network, it's 8082. But these are two different blockchains. So definitely don't configure your wallet here and claim from the faucet in that network. It can be a little bit confusing. Just stick to the Notion doc and you will be just fine. Um, and coming to the track and the bounties, so we have kept it very generic and very open. We want to see what are the things you come up with. Like we don't want to restrict on what you can build. So definitely try to build a DApp on Shardeum. We have an open track, we have a DeFi DApp, an NFT DApp. All of these things already has starter templates in that a boilerplate which we just gone through. So that should help a bit, but you need to build a lot more on top of it. So and the documentation and resources. So apart from the network page, everything in the Shardeum docs is still relevant and useful for you. Nothing changes. Both the networks are different blockchains, but how Shardeum works under the hood is still same. So everything else you find here is relevant. And what else? So yeah, you have the Shardeum Dapp Boilerplate repo link here also, and Shardeum University is our education university initiative in which there are courses you will find about Web3 and like with code examples, and we are launching new courses continuously. So yeah, that's pretty much it. Definitely use this Notion site as your primary resource while building on Shardeum, and you will be just fine. And yeah, I think now we can take some questions. I think we are probably a little bit out of time also.
Yeah, I know that there's some questions over in the questions tab. If you want to just navigate to there, I noticed that there were some in the chat as well, but if everyone in the audience could just pop them in the questions tab, that would just make it easier so they don't get lost in the chat. The first question is, are there any DeFi DApp or token yield vaults already running on Shardeum so that we can leverage interactions in our project?
Good. So yeah, regarding DeFi dApps, so there are multiple DEXs which are being built, but all of those are being built on the public Sharding network, which I also showed in the docs, um, like which may be a little bit unstable and which may be subjected to reset in the near future. So probably that path won't be useful, but uh, in this network you can deploy your fresh uh, like dApp from scratch or token build walls from scratch if you want. But yeah, what do you expect in solutions products with applicability in everyday life? Exactly. Yeah. Please, don't build another NFT minter. So the dApp boilerplate already comes with an NFT minter, but now how can we use that to have a real world use case? For example, that NFT minter tied to a real world use case. At the under at the layer uh, between the user and the blockchain, it's still just minting an NFT, but what is the application of it can be thought through, and you can put in more thought into that and build out a more useful application. Just don't build a one-click NFT minter kind of applications. Uh, but yeah, can we create our own token with Shardeum and how? Yeah, you can. If you want, if you're referring to an ERC20 token, just like you would do in any other EVM network, you can use the Open Zeppelin library if you're not aware of. Let me see if I think my laptop is heating up. That's why network issues. Cool. Let me just drop the Open Zeppelin contracts. So use this library. This is the golden standard in Web3 of contracts, and you can deploy your own token. You can just import stuff from there, and you'll be able to. Cool. I've shared it on the chat. What is the actual use case of Shardeum POAPs? Can they work as Web3 reputation score criteria? Yeah, you can build a Web3 reputation score based application. Like that can be built. That's a good idea. That's something which is not present currently, a POAP based. We do a lot of events, IRL events. We call it Shardium Proof of Community. There are small meetups. So if you build an application which gives you a Shardium POAP when you attend a Shardium Proof of Community event, that will be pretty cool and useful for day to day. Like that's a really good application. What else? Okay, I think I've answered all the questions in the questions tab. Now I'm going to jump into the chat. Is there a list of most important use cases needed? So Shardium is a entirely new network. We are currently in our test net, so we need all kind of applications. It's just that definitely don't create, as I said before, like very generic applications which are very basic, and like always try to like connect your application with a real world use case of, hey, like don't just build a OpenSea for Shardium, build a NFT marketplace which has some newer uh, thought process and some newer features, which might be even at a proof of concept level, but still it's just not a page with displaced NFT. Like if you're understanding what I mean. We can brainstorm more in the Sharding chat also, and you can DM me on Discord too if you want to brainstorm ideas. But yeah, that's the basic idea. And also like nothing is useless, so you're not building any useless dapps. So anything you build is at the end, it's if it's not being used by users at this point of a time, like in the hackathon, you're still learning new stuff, you're trying to integrate a new chain, so there's a lot of things, it's still not useless. So yeah. What about governance apps for DAOs? Yeah, DAOs are going to be very interesting. So from the day one of Shardium mainnet launch, that there will be a DAO which will be able to configure the network parameters of Shardium. So that's how we target the decentralization part of the blockchain scalability trilemma, like blockchain trilemma. So if you want to have a decentralized network, you can't have an internal team call all the shots. So how like you can build a DAO application which lets user do that. Again, at the protocol level, probably you won't be able to do that because right now, at this stage right now, because those repos are not yet open source, but you can have like under the hood, you can do some emulation of like, this is the DAO UI. This is how, like, for example, the Shardim token is being used. Based upon the token, we can do there is a voting UI, and they can change the parameters. Like under the hood, you're still not changing the parameters, but when those repos are live, then you can connect the two things, and that will be useful. So yeah, using governance token, yeah, definitely, yeah. So in Shardeum network, for changing the parameters, the SHM token will be the governance token. So using the SHM token itself, you can set up a quadratic voting system, which the DAO can in future use. So that would be pretty interesting to see. Did I miss any question, Clara?
I think that was all that I could see in the chat. Maybe we just give it a few more seconds, see if you guys have any final questions, please pop them up. I see one in the questions tab. There's a new one if you want to have a look there.
Is the Shardeum Dapp Boilerplate Web2 authentication plug and play as it is? So there is no Web2 authentication, like it's a direct wallet connect thing. Like you're connecting your wallet. I'm not sure if I got your question correctly. Like you can share some more details in the chat. So if you're saying that you want to add a Web2 authentication sort of way, like you can do that too, in which how some of the dApp wallet providers like Wallet Connects are doing. Like you can just sign in with your email and they will provide you a wallet address. So you can use that. I didn't use any of those providers because I wanted to keep this boilerplate very raw. So that you understand each component. So, but yeah, you can use Wallet Connect to have the Web2 login and then the wallet address get created in your dApp. How we define the value of token liquidity. Okay, so value of token, have it fixed for now. When this is testnet, it doesn't matter. So have it fixed for now. When we have oracles, when we go to the mainnet, at that point of time, these things are going to matter. In your dApp, you can just emulate stuff that one token is this much. Like you can have the conversion rates fixed with a variable. Is account abstraction supported on Shardeum at the moment? At the moment, it isn't, but we are working with some of the teams. We are working with teams like Bioeconomy and all to build account abstraction. So many of these things broke down because how Shardeum works under the hood. Like at the EVM level, it's still an EVM, but on like how account abstraction dApps submit their transaction, those kind of changes are what we are working on, and that will be supported in mainnet, but not at the moment. Um, so yeah, what do you mean by gas fee is constant? So if you're doing a particular work in Sharding, for example, if you're deploying the same contract, for example, an NFT contract, no matter how many times you deploy that, that gas will be constant in terms of dollar value in mainnet. Obviously, in testnet, it doesn't matter. So if a particular transaction takes 1 cent, it will take 1 cent no matter how many transactions are there in the network, because there is no race going on for paying the fees. So the transactions are always constant. If there are more transactions, the network just grows and it's able to process even more transactions. So there's no block limit. There's no race going on for getting your transactions into the block. So in that case, it's constant in Sharding. So yeah.
Let's see. Okay, I think DJ just asked, how does that compare to modular smart contracts?
Where's the question?
So that's in the chat just now.
Okay, how does that compare to modular smart contracts? So I'm not sure of how modular smart contracts work, but in case of Shardium, like you can have multiple instances of your smart contract deployed because it won't be stored in the same shard. So in that case, you can like route your transactions to multiple smart contracts and have even more processing, like even like parallel processing of your transaction. Because again, the entire network is not doing the work for every single transaction. So if you have multiple smart contract instances and you are able to route your transactions to multiple, like how you would do in a Web2 server scenario, like you will be able to. But I may have to read up more on modular smart contracts on how that works. So Do our dedicated testnet makes us eligible for the airdrop? I'm not sure. I don't think I will be answering that question regarding airdrops and stuff. But yeah, anything technical related, you can definitely ask.
There are also someone asking in the questions tab what the block size is.
Yeah, it's same. Each transaction is same as an Ethereum, like 30 million. Uh, like 30 million in a particular transaction. Like it's the maximum gas you can use, but the only difference is that it's not related with the block, because in Shardeum transaction is processed on at the transaction level, like the consensus is done at the transaction level, so it doesn't matter on that. So that's why you won't hit the limit ever. How should we handle new configuration settings on the mainnet resulting from software updates and changes to the code structure? So there is no Shardeum mainnet yet. I'm not sure what you're referring to. Shardeum is currently in its testnet stage, and we are preparing for mainnet in Q2.
Okay, cool. I think that might be it then. I'm also aware that we've gone over time. I don't want to take too much of your time. So maybe any other questions that you guys have, please just pop them in the dedicated Shardeum zone on the Discord channel, and I'm sure that you guys will be happy to answer any questions that you have. So thank you so much, everyone, for joining, for asking questions, for staying engaged. And thank you once again, Sandipan, for joining us and delivering a really, really engaging and fun session. It seems like people are very interested in your technology, and I'm excited to see what projects are being built.
Yeah, very excited to see. And definitely, I'm available on the Discord channel. So tag me or DM me directly if you are building on Shardeum, and I'll be happy to help in any way I can.
Awesome. Cool. Okay. Thank you all then. I will see you all tomorrow for our next workshop. And thank you once again to the Shardeum team. And have a good rest of your evening, day, wherever you are. Bye,
Thanks,
everyone.
everyone. Bye bye.